Hello and welcome to the world of 2D transformations in computer graphics. First of all, let us define what we mean by transformation in computer graphics. So transformation is defined as any change or editing what you do to the graphics content. Some of the basic transformations include translation, scaling, and rotation. And other auxiliary transformations are reflection and shear. We'll see the basic transformations first. First of all, we begin with translation. Translation is defined as moving a graphics image or object from one location to another. Let the initial coordinates of the object be represented as alphabet capital O, which is defined by the Cartesian coordinates x old and y old. And let the new coordinates of the object O after translation be represented as x new and y new. If this old coordinate x old y old is translated through translation distances tx and ty along the x and y axis of the Cartesian coordinate system, we will get the new coordinate representations for x and y as x new is equal to x old plus tx and y new is equal to y old plus ty. That means in order to get the translated new coordinate representations, we have to add the corresponding translation distances along the x and y directions. We can see the matrix representation forms here as a column matrix x new y new representing the translated coordinate x ordinate and y ordinate is equal to the column matrix x old y old added with the translation matrix column matrix, that is tx and ty. Now we can represent this Cartesian coordinate xy in terms of the homogeneous coordinate triplet xy1, where the homogeneous factor is taken into consideration as unity. Then this transformation translation can be represented in terms of matrix multiplication as given in the right hand side here. So then the column matrix becomes a 3 by 1 matrix where x new, y new and 1 are the elements, and the transformation matrix, the translation matrix becomes a 3 by 3 matrix which is multiplied by a 3 by 1 matrix. So thus we can represent even translation in terms of matrix multiplication if we represent the Cartesian coordinate system in the homogeneous coordinate triplet. The next basic transformation what we are going to see is the scaling. So scaling transformation is the one which changes the size of the geometrical object. It may increase or decrease the size of the object. So here we consider something called as scaling factor, which is the major factor which determines whether the size of the object has to be increased or reduced. If the scaling factor is greater than unity, then the object size gets increased, and if the scaling factor is less than unity, then the object size gets reduced. Suppose the initial coordinates of the object O is again represented as x old and y old in the Cartesian coordinate system, and we take the scaling factors along the x and y directions as sx and sy, then the new coordinates x new and y new after implementing the scaling operations will be got as x new is equal to x old multiplied by the scaling factor along the x direction, that is sx, and y new is equal to y old multiplied by the scaling factor along the y direction, that is represented as sy. The same can be represented in matrix form as x new y new is equal to the 2 by 2 matrix, the scaling transformation matrix, multiplied by x old y old, that is a 2 by 1 matrix. And again we can represent the same scaling in terms of homogeneous coordinate triplet as x new y new 1, the column matrix, the 3 by 1 matrix, which is the result of the multiplication of the transformation matrix, scaling matrix, which is a 3 by 3 matrix here, multiplied by a 3 by 1 matrix. The next basic transformation what you are going to see is called as rotation. So rotation is the basic geometrical transformation which moves a geometrical object through a circular path, or we can say through an angle. So let a point on the object O has to be rotated through some angle theta, which is defined as the rotation angle here, in a 2D plane. Let the initial coordinate location of the O be represented as x old and y old, and the new representation that is given as O dash, which is given as x new y new. So the initial coordinate O was subtending an angle phi with the x ordinate of the Cartesian coordinate system, and once it gets rotated through an angle theta, it comes to the position O dash, and the entire angle which the O dash subtends with the x axis will become theta plus phi, and let the radial distance be represented as r. Once you have like this representation, we can see in this diagram like the Cartesian coordinates of O, that is x and y, can be represented in terms of cos phi and y phi, cos phi and sin phi. So here x is equal to r into cos phi, and y can be represented as or y old, x old is given as r into cos phi, and y old can be represented as r into sin phi. And similarly, O dash can be represented in terms of trigonometric functions as x new can be represented as equal to r into cos theta plus phi. So if you expand cos theta plus phi, that is cos a plus b formula, you will get as cos phi cos theta minus sin phi sin theta, and if you substitute the values of r cos phi as nothing but x and r sin phi as y in these equations, you can get the modified equations for x new and y new as x old into cos theta minus y old into sin theta for x new, and y new as x old into sin theta plus y old into cos theta, where theta is nothing but the angle of rotation. So the same equation can be represented in matrix form as given below here. The column matrix x new y new can be obtained by multiplying the 2 by 2 matrix with the 2 by 1 matrix as given here. And same rotation transformation can be represented with homogeneous triplet as a 3 by 1 matrix, which is the resultant matrix, which is the product of a 3 by 3 matrix by a 3 by 1 matrix like this. So that is all in this small introduction to the basic transformations in computer graphics. Thank you.